Hi, this is Randy with Sophos Tutor, and I just want to say a quick thank you for clicking on this video. Also, if you haven't already, please click subscribe to Sophos Tutor, as it really helps out with the channel. Thanks.
The question that we're going to first deal with is from the College Panda ACT math book by Nielsen Fu. The question that we will be tackling is on chapter 15, angles. And it's going to be the last question in the chapter, so I believe it will be on page 102. Now, just so you know, this edition is from 2017. I forget if this is the first edition or second edition. I imagine this is the first edition. So this is question 11. And it says, in the figure below, the segment AB is parallel to segment ED. The measure of angle CDE is 36 degrees, and the measure of BCD is 67 degrees. What is the measure of angle ABC? Well, since I don't want to mark up my book, I am going to sketch out the figure on the whiteboard. And we want to know what angle B is. And we're told that segment ED is parallel to AB. Let me go ahead and redraw AB so it does indeed look parallel to ED. More like that. Okay? All right. So where do we begin? Whenever we're dealing with angles, we almost always want to identify where parallel segments are. We do that because we want to prioritize what we call transfer of information. When we have parallel segments, parallel lines, there are usually opportunities to transfer the values of angles to other places. So if we go back and look at a more typical figure involving parallel lines, and this line that crosses two parallel lines, we call that a transversal. Whenever we know one angle, let's say this is 72 degrees. What's great about parallel lines is that one transversal will essentially create duplicate intersections. So since this transversal is crossing this line at 72 degrees, then we expect that this transversal will also intersect this line, which is parallel to the original line, also at 72 degrees. Okay. And then when we use the principles of vertical angles, that is, angles that are opposite each other in an intersection, we expect that the vertical angles will also be 72 degrees. Now, adjacent angles, which we would call linear pairs because the two adjacent angles create a straight line, these linear pairs are going to be supplementary, which means their angle measurements will add to 180 degrees, which means that this angle should be 108 degrees. 108 plus 72 is 180. And then, of course, using the vertical angle rule, we'll know that all the other angles are 108 degrees. So we see how very simply, just by knowing one angle in an intersection where we know a transversal is hitting a parallel line, we can transfer a lot of information from that one piece. We were able to transfer other angles that were equal to the original angle, and we were also able to identify angles that are supplementary to that original angle. So we want to exploit that power in this figure. So how do we do that? Because currently we don't have one particular line that crosses both parallel lines. Well, in these sorts of advanced problems, we might need to give a little bit of assistance. That is, we might need to extend one of these lines in order to create a second intersection effectively. My instinct right now is how we can exploit this 36-degree angle since it shares a ray with one of the parallel lines. So it makes me want to extend the other ray and see if this other ray can hit the other parallel line. Indeed, we can extend it, like so. Right? Now, if I extend the other way, and I extend this other line, you'll see that we will now create two duplicate, identical intersections. Both of these intersections are going to cross at 36 degrees. Right? So if this is a 36-degree angle, then that means this would be a 36-degree angle. And due to the vertical angle theorem, this angle right here on the inside will be 36 degrees. Okay? The power of transferring information. Okay? Now this 36-degree angle will be useful because it is one of the angles in this triangle that we've created, with one of the angles being the unknown angle that we need. We know that all three angles of a triangle add up to 180 degrees. We know one of them. So if we can figure out what the second one is, we should be able to figure out the third. So how do we find this missing angle? Well, it is adjacent to this 67-degree angle. And it forms a linear pair with that 67-degree angle. So we expect this angle C to be supplementary to 67 degrees. So we'll just go ahead and subtract 67 from 180. And what will we get? We should get 113 degrees. So we expect this angle inside here to be 113 degrees. Well, we now know two angles inside of a triangle. Because they all add to 180, we should be able to figure out the third. So we can just go to our calculator, but I'll just go ahead and do it by hand. Let's go ahead and just add the first two angles together. 113 plus 36, 149 degrees. And so now we're going to go ahead and just subtract 180 from that. So this should be, I believe, 31 degrees. Just verify. Yeah. So the mystery angle is 31 degrees. And if we check our book, there is an entry for 31 degrees. It is letter B. And let's go ahead and verify the solution. Solution's on page 231. And we want the answer to question 11. And indeed, the answer to question 11 is B.
Thank you so much for watching. Now, if you liked what you saw, please click the thumbs up button below. Also, if you want to watch more of my videos, or you want to catch me on an office hours live stream, please click subscribe to Sophos Tutor.